So here we're going to look at the mean of a frequency distribution. What this means is a mean of basically a histogram. Where's the average, where's the average of that histogram? And so I've got an example here. It says at a local hair salon, various treatments cost according to the chart below. And so it's got the cost there. And it says on Monday, 23 people got a cut, 7 got a color, 4 got a perm, 2 a Malibu, and 6 a blowout. Whatever a Malibu and blowout are, I don't know, I'm a guy. But what was the mean cost per treatment? So you can't just, I think a lot of people at first glance might just say, well, the average cost per treatment, you just add up those 5 and divide it by 5. But that's not what we're saying. We're saying 23 people got a cut, so that's going to mean that the cut, there was a lot more money that was brought in by haircuts because there was 23 of them as opposed to only 2 people got a Malibu that day. So really what they're asking is for you to say, well, if 23 people got a cut, then you're going to do 27 plus 27 plus 27 plus 27 plus, and keep doing this until you add up 23 of those. So it'd be 23 27s. And then you'd have 7 colors. So it'd be plus 90 plus 90 plus 90 plus, there'd be 7 90s, right? And then there would be 4 perms, so plus 95 plus 95 plus 95 plus 95. And then there were 2 Malibus, so I can just write those out, plus 36 plus 36. And I didn't do a good job spacing this out, but hey, I can cheat a little bit. Here we go. And then 6 blowouts, so there'd be 6 of these. And then all you do is, since you're finding the average, is you divide it by how many total. And so that would be 23 plus 7 plus 4 plus 2 plus 6. Now, if you've taken elementary school math, you probably know a quicker way of doing this rather than adding all of these numbers up. Well, if there's 23 27s, you can just do 23 times 27. And then if there's 7 90s, you just do 7 times 90. And then there were 4 95s. There were 2 36s. And there were 6 50s. And then when you add all these up, let's see if we can do this kind of quickly. 23 and 7 is 30. 4 plus 6 is 10, so that'd be 40. Plus 2 is 42. So it's really doing what we did up there in red, except I'm just kind of making it a little bit more concise. So let me plug this in my calculator. And when I do that, I get 2003 on top over 42, which is about 4769. So if you were to, ask what did the average person pay that day, it was $47.69. Now, you might argue that the mode would be the one that would describe this data set the most, because not a vast majority, but a majority of the people got a cut, and then the rest was other things, but the cut was the most indicative of this data set. But as far as the mean of the frequency distribution, that would be $47.69. Okay, next example. What if we want to find the mean of this frequency distribution, where instead of set prices like the previous example, now we have classes, or like intervals of numbers. In this case, it's ages. And so what I did was I kind of did this before doing this video, and I took this and I made a histogram out of it, and I want to show you how you can find the average in that histogram or the frequency table depending on what you're given. And so the problem is, if we look at, like, let's say we look at this first row in this data set, it says the ages 18 to 22, there were 5 people that were in that group. Now the problem is, were they all 18? Were they all 22? Because that's going to be a big difference, because, you know, if they're all 18, then you'd have 18 times 5, but if they're all 22, then it'd be 22 times 5. Well, the problem is we don't know. We don't know how many there are and in which, you know, if there's a bunch of 18 or a bunch of 22, or if they're all 20, whatever. So what we're going to do is we're going to give it our best estimate. And the way we're going to estimate is we're going to find out the middle. And in the middle here is 20. It'd be 25, be 30 for the next class, 35, and 40. And we're just going to assume that everybody is in the middle, and then that way, if some are above and some are below, it's going to kind of average out. But this will, you can only get really an estimate. You can't get a perfectly accurate answer because we don't know what all of the data points are if we're given this information. So it's going to look just like the previous problem. We're going to do 5 times, and then we'll do the middle, so 5 times 20. And then for the next one, we're going to do 10 times the middle, so 10 times 25. And then on the next one, we're going to do 7 times, not 70, sorry, times 30, because that's the middle of that, and then 2 times 35, and then the last one would just be 1 times 40. And then we just divide it by how many total data points there are. So if we have 5 plus 10, that's 15, plus 7 is 22, plus 2 is 24, plus 1 is 25. So let's plug this in our calculator. And when we do that, we get 26.8. So the average here would be 26.8, which is somewhere around where that red arrow is pointing. This would be a slightly skewed right distribution if you're looking at this. And so that means that the median is going to be a little bit to the left of that, where that blue arrow is pointing. And that kind of makes sense, because if there's 25 data points, and in those first 2 bars, that is 15 of the data points, that means that the middle is going to be somewhere around there, because 12 and a half would be the middle. 12 and a half data points would be the middle. All right, so that's how to handle if you're given a histogram. Basically, you look at the histogram and you treat it like a frequency table, and then just find the mean of that frequency distribution from that. Okay, last thing is mean of a frequency distribution. A weighted average, and this is basically what your grade book does for you. And so here's an example where it says, in Mr. Broad's science class, grades are broken up in the following manner. Tests are 50% of the grade, quizzes 20%, labs 15%, homework 10%, and class participation is 5%. And so Hannah, she got the following scores in her science class, and we'll just assume it's out of 100. And so it's what's her weighted average. And so once again, this is basically what your grade book is doing for you. And so if you think of it in terms of, 100%, each of these pieces is going to contribute some toward that 100%. And so for the tests, it's going to be 88 times 50%, so 0.5. For the quizzes, it's going to be 92. So Hannah's a good test and quiz taker, it looks like, times 20%, which is 0.2. For the labs, it's going to be, ooh, the labs didn't go so well. That was 56, but it's only 15% of her grade, so it'd be 0.15. The homework, she got in every day. She's a good little student. She got 100%. Unfortunately, that's only 10% of her grade, so 0.1. And then the class participation, we'll call that C. She didn't participate much. She was really shy, but it didn't hurt because it's only 5%, so 0.05. And with this one, you add them all up, and that's going to be your answer, but you don't have to worry about dividing by how many there are, because basically you're dividing it by 100%, which is just 1. So all you have to do is type this in your calculator, and when you do that, you get 81.8. So this would be Hannah's weighted average. So that's basically a B minus. She got around an A minus B plus average for tests and quizzes, but then the labs and the classroom participation really brought her grade down to that lower B range. And that's how you would figure it out. You'd say how much percent is each one contributing, and then you multiply it by what you have in each of those categories. All right, so that's weighted average and